Hello and welcome to 7th lecture of 8th chapter in our comprehensive course on data science, machine learning and artificial intelligence. Now, so far in this chapter, we have done this much. 1. Filtering the data and sorting the data, that is for a pandas data frame, filtering it and sorting it. Then using group by and aggregate functions for a pandas data frame. Then using merge for a pandas data frame, using join for a pandas data frame, and this last topic is about using concatenate or concat function for a pandas data frame. Now, where is this concat function used? Concat function is used to stack or v stack, horizontal stack or vertical stack two data frames. For example, suppose this is one data frame and this is another data frame, and I want to arrange them like this, one above another. Okay, then I can use concatenate with axis is equal to 0. Okay, that will create one above another. But when I say one above another, one thing should be clear, that means the width of this data frame and width of this data frame should be equal, or in other words, number of columns in this data frame and number of columns which I am attaching below it, so that a large big stack is generated, that both should have both must be same. That is with axis is equal to 0. Similarly, I can also, this is again one data frame and this is another data frame, and I can join them this way. So at that time they are side by side join. Such a side by side join is like horizontally pasting one data frame or H stack, that kind of situation, and that means it is creating a wider data frame from two thinner data frame. But again, for that, number of rows in first and the number of rows in second must be equal. So if this has 400 rows, this also has 400 rows, then the combined data frame will have also 400 rows, but it will have more number of columns. So this is also one kind of stacking. This is done by concat with axis is equal to 1. Okay, so just remember, axis is equal to 0 means one above another, and for that number of columns must be equal, and axis is equal to 1 means one beside another, and for that number of rows must be equal. Okay, now this is the standard format for pandas.concat or pandas.concat, but if you have already import pandas as pd, then pd.concat, that is clear. Okay, so pd.concat, and this is the format. Objects. So objects means a comma separated list of all data frames which you want to concatenate together. So it is interesting that this concat will not only work for two data frame, but it can work for 3 data frame, 4 data frame, 5 data frame, any number of data frame. So if there are 5 data frame, then here I will just write df1 in a list, df1, df2, df3, df4, df5. With axis is equal to 0, it will put all one above another and create a high, very high stack. Okay, but with axis is equal to 1, it will put one beside another and create a very wide stack of 5 data frames. So it can contain any number of data frames. That is what these objects means. And not only that, that object, I said that you have to supply comma separated list, but it can be not only list but any sequence. Okay, so that is important, that any sequence type object can also be provided. Axis is equal to 0 is the default behavior. That means if nothing is specified about axis, then pandas data frames will create one above another. That means one data frame has 3 columns and 100 rows, and another data frame has 3 columns only but 500 rows. Then when you concatenate them using axis is equal to 0, then you will get 3 columns but 100 plus 500. So that means you will get a higher data frame, very long data frame. You are concatenating along axis. So along axis is equal to 0, then along that axis the dimension will increase 600 rows. Okay, and join is equal to outer. So join is equal to outer is also default behavior. That means if sometimes the things do not match, then concat tries to include everything from both the data frames which it is concatenating, both or maybe 5, then it will try to include everything. And whenever it does not find any match during trying to include everything, then it will put a none there. Now this ignore index is equal to false. That is also default choice, but many times we needed to do that. Ignore index is equal to true, and we will see what is the meaning of that. Keys is equal to none, levels is equal to none. These are various possible arguments. Sort is equal to false. That is the default. Now again, there is no need for me to discuss these arguments here, because it is better to take one example of each. However, these two require some explanation. Verify integrity and sort. So verify integrity means it will check for duplicate indexes. So that means if one data frame has index 0, 1, 2 and another has index maybe 2, 3, 4, then index 2 is being repeated 2 times in first data frame also 0, 1, 2, and second data frame also 2, 3, 4. So when you vertically stack them, then what will happen is the two rows with index 2, they will appear that means two rows will appear for index 2. Okay, now sometimes it is required. For example, if you are ultimately transferring your data to from pandas data frame to SQL, and suppose that index is going to become your primary key of the database, so then the primary key must be unique. So this will integrate violate the integrity. So then you have to put this verify integrity, then it will check. If it is set to true, then it will verify. By default it is set to false, it does not verify. And sort also by default is false, but if you set it to true, then it will set sort on the basis of index. Okay, let us take example, then the rest of the parameters becomes very clear. So first, as always, we first create the data frames which we want to take as example, and then proceed further. So this is my creation of data frame. First data frame has two columns AB and three rows. Second data frame also has two columns AB only, and it has two rows. So let us first print them. So this is my first data frame AB, and this is my second data frame. As soon as it is clear that both have equal number of columns, so they are candidate for stacking one above another because their horizontal width is same, so they can be stacked one above another. So one above another means vertical kind of concatenation, and that is done by setting axis is equal to 0, which is the default choice. Okay, so then you can write pd.result be concat or anything, but I am writing the names such that they are indicator. So pd.concat and in bracket df1 comma df2. So these are the two data frames which I want to concat, and I have nothing specified for axis. So the default is axis is equal to 0, and for axis is equal to 0, the prime condition is that the number of columns in the both the data frames must be, which you are concatenating, they must be equal. So here they are equal, 2 and 2, fine. So then you can concatenate, and you can see that you get this kind of situation. However, the result is fine. Look wise it is okay that one data frame is placed just above another, and now you get a single data frame. Index is not proper. So I would like not to retain original index, because original index was 0, 1, 2 for these records, and 0 and 1 for these records, A4 and A5. So it has retained that. Okay, it has not ignored that. But I would like an index 0, 1, 2, 3, 4 like that in one sequence. So then what you write is ignore index equal to true. So which index it will ignore? It will not ignore the index of this new data frame, but it will ignore the index of original data frames, that is 0, 1, 2 and 0, 1. It will ignore, and it will then assign a new index which will be in proper sequence. So this is same thing, pd.concat df1 df2 here, but I have added one argument, ignore index is equal to true. And this is how most of the time we will use it in putting one data frame above another. So axis is equal to 0, with that ignore index is equal to true will always come. Here axis is equal to 0 is not appearing because that is the default choice in the syntax of the concat. So it is understood that axis is equal to 0. So with axis is equal to 0, ignore index is equal to true must come. Okay, so if you now, then you can see that now index are nice, 0, 1, 2, 3, 4. Here index was 0, 1, 2, 3, then 0, 1 like that. Okay, so this you must remember that with axis is equal to 0, the two data frames must have same number of columns like this and this, same columns in fact, and we do not specify, but it is axis is equal to 0 and ignore index is equal to true should be used for proper index. Okay, now what happens if there are different columns? Okay, and still I insist that I want to concatenate one above another. Say this is one example. Now here what is the situation? This is column A and B, and in column A there are A1, A2, A3, 3 records, and here in B numbers 1, 2, 3, 3 records. The second data frame has also column B, so that name is fine, but column C is there, so there is no A, and column C is there. Now that means the column names are differing from each other here. Okay, this has no C, this has no A column. Let us first print them. So this is AB 2 columns, and this has BC 2 columns. Otherwise they are okay, dimension wise this also has 2 columns. So I have a potential, that means that I can put them one above another. But problem is that the 2 columns of these are AB while 2 columns of these are BC. So what to do? Then you consider inner join. Inner join means that kind of situation. We have done that diagram repeatedly. So this kind of situation. So only intersection will be taken. So inner join means at that time, if you insist that I want to do vertical stacking of these two data frames, this is first and second, then I have to forget about the column which is not present in both. So that means this is not present in both. So in result column A will not come, and this is not present in both. So that will also not come. So only common or intersection column B will come. Let us print and let us check. Okay, so that is this kind of situation. Again, I'm saying in previous lecture also I told you this thing, that don't just go on clicking next, next, next in the Jupyter notebook. First think what will be the output, and then you decide that then you check whether that kind of output is obtained or not. Still this issue remains that indexes are not proper. So for that, you know the command ignore underscore index equal to true. That will give me proper index. Okay, that is the in proper sequence. So it is here ignore index equals true. So that thing must come. And when you write true, it should change its color. If it does not change its color, that means perhaps here I think it is allowed. Perhaps inner join also ignore underscore index equals true. Let us execute. Yes, it works. So fine. So 0, 1, 2, 3, 4, 5. Okay. I think when you write true in inverted commas, then that color change does not. Yes, here it was without inverted comma. That's why it worked. That is okay. But yes, color change must be seen. So now you can see only the column which was common between the two data frames B, that is there, and the indexes are also arranged properly. Now concatenate with outer join on the columns. Same two data frames. Now I can concatenate same way pd.concat df1 df2 on axis 0 only, that means one above another still, but join is equal to outer, and there also I can write ignore index is equal to true, this part, just for proper visibility of index. That is as such optional, but fine. Should always write that whenever axis is equal to 0, this thing should always come. Now outer means what? Outer means everything from the both. If you remember, full join or this full or outer, that is outer. So in that case here what will happen, that you can see. Okay, where is that? Okay, here outer and ignore index equal to true. So these are the two data frames. AB are the two columns in first data frame and BC. Now when I say outer means I will take all the columns. So AB will also be taken and BC will also be taken. So how many columns will come in the result? Then it will have ABC, 3 columns it should have, and rows will be one above another. So that means there should be 6 rows. So if I do that, you can that is inner. Sorry, this is the outer. So you can see that ABC all are there. Okay. Now the issue was here 0, 1, 2 was there, but for 0, 1, 2 there were no records in C. So okay, let us avoid this ignore index is equal to true, and let us see then whether better output is obtained. No, that is also still same. So for C, this 0, 1, 2 that has no records. Okay, because though index of both appear same, 0, 1, 2 and 0, 1, 2, but 0, 1, 2 of this data frame and 0, 1, 2 of this data frame, they are not the same, because here for 0 the records are A1, 1 for column AB, but what are the values for column CD? Nothing. And similarly here for index 0, 1 the records are 4, 5 for column BC, but what are the values for I mean A column? Then there is nothing. Okay, so in that case you have to write, if for C here there is nothing, so that's why you write none. For this there is no C column, and for this there is no A column, so in A column none will come. So none will come, and for first there is no C column, so in C column none will come. So like that. Okay. Now ignore index, whether you write or don't write here, it does not make any difference. Yes, of course, it makes that much difference that appearance wise the index will appear in one sequence, but at least in none it does not make any difference. Not even appearance wise. Yeah, appearance wise it makes difference. Fine. Now concatenating data frame horizontally. So far we have done all cases when axis is equal to 0, so one data frame is put above another, and therefore the number of rows in the result data frame always increases. Okay, but now we are taking the other case where we are putting one data frame beside another, and that is this case, concatenating data frames horizontally. So if I put that way, the number of rows in the resultant data frame will remain same. This has 100 rows, this also has 100 rows, and the result will also have 100 rows. But number of columns will increase. This has 5 columns, this has 3 columns, then these two will have 5 plus 3, 8 columns. So width wise, the data becomes wider. The result will have wider, or width dimension increases. Okay, first let us create two data frames. So A and B, 3 rows are there, and C, D, and E, 3 rows are there. As I said here, I have written clearly that the condition for side-by-side concatenation is that number of rows must be same. So if you write that and then concatenate like this, then I think I missed the one result, right? Okay, yes, these are two data frames just created. Now concatenating with different indexes. So first, this I should concatenate this only. That would be better. Okay. So then print pd.concat and df1 comma df2. But this time I want to do width wise. So axis is equal to 1. Okay. So that means I want to put side by side concatenation. So axis is equal to 1. Like here only, this way. But axis is equal to 1. Yes, this should be put in any sequence data. So I will prefer to put it in Python list. And then uh, let us directly print it. So you can see this kind of output is obtained. Now here what is happening for these two, that you should understand. This has 3 observations. This also has 3 observations. You can see these are A and B columns, and these has 3 observations each. So these are C, D, and E columns. You are concatenating with axis is equal to 1. That means you are concatenating width-wise. So the resultant data set also has 3 rows, 3 observations, but it has more number of columns. It has become wider. Side by side concatenation, axis is equal to 1. This column axis is called axis is equal to 1, and this vertically downwards 0, 1, 2, that axis, that is called axis is equal to 0. So if you concatenate along axis is equal to 1, then dimension in that direction will increase. Okay. Now concatenation with different indexes. Now here nothing was specified about indexes. So that means default indexes were created. So that is why first index is 0, 1, 2, and the next index is also 0, 1, 2. See, sorry, here, and the result index is also 0, 1, 2. But now let us say first data frame which has 3 observations and 3 columns A, B, and C, and index is 0, 1, 2. Second data frame has 2 columns E and D, and E has 4 observations and D also has 4 observations, and index is 1, 2, 3, 4. So let us first print those two data frames. So this data frame is now 3 by 3 data frame, 3 rows and 3 columns, 3 rows and 3 columns A, B, C. Okay. The keys of the dictionary, they become the column. While this is 4 by 2 data frame, 4 rows and 2 columns. 4 rows and 2 columns. Now I am doing pd.concat with df1, df2, and axis is equal to 1. That means I am doing side by side concatenation. So first of all, you have to decide, can I do it? So as such, it looks there is a problem, because I said that for concatenation you should have same number of rows. But here there are 3 rows in the first data frame, and there are 4 rows in the second data frame. So that means it is clear that this 2 when concatenated will have some nonce, because for 4th row there is nothing in the first data frame. So some nonce must come in the column A, B, and C. Okay. So let us see if output is obtained or not. So here nonce have come in column A, B, and C, because for the 4th row there is nothing in that, and also not only 4th row, but even index values are different. This, if this would have been 1, 2, 3, and this would have been 1, 2, 3, then none would appear only in the 4th. But this is 0, 1, 2. So that means only 1 and 2 are such indices which have values for both data frames. So here for 0, there is nothing in the second data frame. So none will come in column E and D for 0th row. So none will come in column E and D for 0th row. Okay. And similarly for 4th, there is nothing in this 1, 2, 3, there is something, sorry, 0, 1, 2. So that means 3 and 4, these two indexes, there is nothing. Those indexes themselves are not present in first data frame. So for 3 and 4 index, these will have none. So here you can see in the result, for 3 and 4 index, column A and B has none. Because for column A and B, A, B, and C also, because for column A, B, and C, 3 index is not there at all, and 4 index is also not there at all. So that means there are different indices. So you can do horizontal concatenation with different number of rows, but then some nonce will enter into your result data frame. Then you have to treat those non values by some either imputation, by median, mode, or mean, etc. Now this is one application which is sometimes required, very rarely, but sometimes required, in which you are creating a hierarchical index using a command called keys. So for suppose this is my first data frame. It has 2 columns A and B, and in each column there are 3 observations. These also have same 2 columns A and B, but in each column there are only 2 observations. Now first I print them, and if I have not given nothing for index, in previous case I created custom index also by specifying them after my value in the dictionary. So but here and here, but here I am not specifying anything, dictionary is enough. So then there will pandas will allocate the default index 0, 1, 2, because there are 3 rows, and 0, 1 because there are 2 rows. Okay. Now concatenating with df1, df2. Okay. And I want hierarchical concatenating, hierarchical index. What is the meaning of that? That becomes clear only when you see the output. But in that case, pd.concat df1, df2, again, axis is equal to 0 is the default, so it will be one above another. That is clear because I have not specified anything. But I have to specify something like this: keys is equal to df1, comma df2. So concatenate these two data frames using keys is also equal to the keys of df1 and df2. So then the resultant data frame will have two keys. So let us see. You can see this, that this was my first data frame. If I ignore the df1 part, then that is my first data frame, this much, 0, 1, 2, this, okay. And this was my second data frame, it is this. But here, two level indexes are coming. So this is one level of index, df1 and df2, and this is next level of index. So df1 0, df1 1, df1 2, and similarly df2 0, df2 1, and df2 2. Okay, so this type of hierarchical indexes are sometimes required. So at that time you will use keys parameter along with pd.concat. Okay, so key takeaways are that pd.concat allows concatenation along axis 0, that is putting one data frame above another, default behavior, or axis 1, that is putting one data frame beside another. Okay, then if you put one data frame above another, or even this case, and if you want to reset the index back, then write ignore index is equal to true. That means it will ignore the original indices of the two data frames which are being concatenated, and it will pandas will give a new index. Okay, join parameter can be used for mismatched index. So somewhere here we had a mismatched index, so that type of index can be handled using join parameter. Okay, and outer, which is default behavior, will include all columns, while inner will return only the common columns. So we had done example of both. Outer, so here this was having column AB and this was having column BC. Then when you do outer concatenation, then this is outer, then it will have column A, B, and C all. Okay, if no matching observation is found, then that will be filled by n, none, that is. Then inner will have only common column. So this has two column AB and this has two column BC. So the resultant data frame will only have common column B. A and C will be ignored. So that means resultant data frame will have only B column. That is like this kind of situation, right? So that is one takeaway. But outer is the default behavior. So pandas will try to take all the columns, and that is why concat is notorious in one case, that it by default takes outer, and therefore it will introduce none. That is where is that example? Somewhere outer example was there. So if two data frame which you are concatenating, they are exactly having same columns, AB, then another also has AB, then concat behaves the best. If they have different columns, then when you write outer, this is that case, and outer is the default behavior. So AB and BC, then in that case, this outer, when you write, wherever there are missing observations, they will be filled by none. Okay, so that is one limitation of concat, or limitation means at least you should remember that when you use concat, so at that time you should at least remember that thing, because its default behavior is such that it includes all columns or all indices, and therefore if no matching value is found for a particular column or index, then it will fill none. So concat fills none very quickly, and therefore merge or join are better option. Merge is particularly good option. Okay, then inner will that is not a default behavior, but if you, then it will return only the common column that we have already done, and hierarchical index can be created. Most commonly the default behavior is kept with a concat. That means most commonly concat is used for joining two arrays one above another, like this. Okay, axis is equal to 0 and ignore index is equal to true. Fine. Now from here, this is I think one example. Okay, so let us take one example. This is January sales of your firm, and these are the dates, 3 rows. It can be instead of 3 rows 30 rows. Okay, but just for simplicity. And these are the sales made on that day, and these are the employee IDs who made that sales. Now after January, suppose the person who is keeping the data, he has left your job, and another person comes and by mistake he creates another Excel sheet or another CSV file, and in which he enters these details. Columns are same: date, sales, and employee ID. Date, sales, and employee ID. But now I will have two different data frames to handle. So I would like that these two should be joined together into a single Excel sheet. And as I said, instead of 3, it can be 3000 or it can be 10,000 entries, then it would be very difficult to do that kind of situation for each of the data frame. So then, or it can be for January it is different, February it is different, March it is different, and for each there can be 30 or 31 or 29, that kind of rows. Columns are same for all, but there are 12 months. So will you do the analysis for each month one by one separately? No. You will, first thing which you will do is you will put all the data frame one above another. When I say one above another, it is clear that the default behavior is correct. That is axis is equal to 0, so I don't need to specify that. And the two data frames, I will put them as a comma separated list, and I will write axis is equal to 0, ignore index is equal to true, and I will get one this kind of data frame. Okay. Now it is better, and think that there are 12 months, and in each month there are maybe 30-40 records, or it can be 100 records also, because for February 1 it is not necessary that only one cell was done. For February 1 only, second cell was done, third cell was done. So on each day there can be 10 transactions, and there are 30 such days or 29 such days. So February will have 290, March will have 310. So you can imagine that analyzing each month's data separately is very tedious, and it is not done that way. So instead we just concatenate, and all the months spreadsheets we will pass as a comma separated list: January sales, comma February sales, comma March sales, comma April sales, comma May sales, and so on, because this can take any number of arguments. That is one big strength of concat, that it can, in one go, it can take any number of arguments. Okay, join can only take 2 arguments. Merge can also take 2 arguments, but this can take any number of arguments. That is one very big strength of concat. Now another example, suppose this is one data frame, 4 columns A, B, C, D, and in each column there are 4 observations. So that means this is 4 by 4 data frame, and its index is 0, 1, 2, 3, custom index. This is also same 4 columns A, B, C, D, in which some other different observations and different index. Okay, and this is also third data frame with same 4 columns but different observations than first 2 data frames, and this has different index. So if I print the 3 data frames, then this is my df1, this is my df2, and this is my df3. Okay, now here I want to concatenate them. So then I concatenate and save that result as result along axis 0. So pd.concatenate, I can pass a comma separated list df1, df2, df3 for all. This is not even required to be written, but I initially prefer to write in explicit manner, just so that we remember that axis is equal to 0 means one above another by seeing the result, and axis is equal to 1 means one beside another. So let us print the output. This is the output of axis is equal to 0. There are no nons, because just one, this above this above this. So that is very easy, because all have same columns A, B, C, D. So there are no nons. There are observations for column A, B, C, D for all 3 data frames, and you have reset index. So then that there is no need of even resetting index, because right from the beginning index is given properly only. So then ignore index is equal to true is also not required. Then fine. But when you concatenate along axis 1, then there is a problem, because when I try to put this on the right side of this, then what will happen is that for index 0, 1, 2, and 3, is there anything in this ABCD columns? Then nothing, because second data frame has no index 0, 1, 2, 3. So for index 0, 1, 2, 3, second data frame will have none, and third data frame will also have none, because it also does not have 0 and 1, 2, 3. Okay. Then similarly for index 4, 5, 6, 7, first will have none and third will have none. And similarly for index 8, 9, 10, 11, first and second will have none. In short, whichever index is specified in that data frame, apart from that, all other indexes will have none values. That is clear, okay, for that. So that is why you get this kind of output. This was my df1, except none if I see. Okay, that means this upper one, because it had only values for 0, 1, 2, 3. So they are printed, but then df2 did not have any value for 0, 1, 2, 3 index. So none. df3 also did not have any value for 0, 1, 2, 3 index. So none. Okay. Similarly, these are 4, 5, 6, 7, for which only the middle data frame should have values. There should be none on the left side. Middle data frame has values, and there are none on the right side. Third data frame also does not have anything for 4, 5, 6, 7. And this is index 8, 9, 10, 11, for which only the last rightmost data frame should have values. So rightmost data frame has values, and rest of that all are none. Okay, this. So concatenating along axis 1, that is along columns, is not that useful, but concatenating along axis 0 is often very, very useful. Okay, concatenating along axis 1 when you are doing, then please be careful about nons being introduced. Okay, now after that, the chapter is over here. This is exercise 8.1. it is a practice for sorting, filtering, grouping, and aggregation. And as we have been doing for all, this is just creation of a synthetic data. So don't bother about from where this is coming. This is data. I have to give you data. Then I am asking you to sort. I am asking you to filter. I am asking you to group. I am asking you to group and aggregate. Fine. Similarly, this is exercise 8.2. Here it is testing, merge, join, and concatenate. Again, first we are creating three data frames: employee details, department details, and employee salaries. And I have to give the data frame so that whenever answer is checked, every learner will have the same answer. Otherwise, I can tell you that you make your own data frame, but everybody will make different data frame, and there will not be any common answer. That's why. Okay. Then you are asked to do merge, and then you are also asked to do perhaps, I think only, yeah, join, and you are asked to do concatenate. Okay. So three things you are asked to do. Fine. So here this 8th chapter is over, and we will meet again in the 9th chapter. Now what is that 9th chapter? If you see somewhere here, 9th chapter, then it is exploratory data analysis. So now that we are armed with our knowledge of NumPy, pandas, and even we have done some little bit introduction about uh, uh, matplotlib library, so we can now do exploratory data analysis of real data sets, which that means that type of data sets which we have to deal with as a data scientist. Okay, so we will do that in next chapter, and from here you can say that your real data science is starting. Before that, 2 chapters on NumPy and 3 chapters on pandas were done, so that should be enough for you to understand how important these two libraries are. They are two backbones, and please revise these 5 chapters, previous 5 chapters, very thoroughly. Thank you.